You ever just stop and wonder what makes the latest AI so good, so powerful? It's not always the big flashy stuff. Turns out some of the biggest leaps forward are these small, kind of elegant changes hidden deep inside their architecture. And today, we're going to unlock one of those secrets.
So let's just dive right in. When you hear about a beast of a model like Meta's Llama 3, what comes to mind? Probably massive data sets and just pure raw computing power, right? And look, you're not wrong. But that's not the whole picture, not even close. There's this super clever component working behind the scenes, kind of like a hidden engine.
See, the real breakthrough here, it's not just about cramming more and more information into the AI. It's about building a smarter brain to actually process all that info. The secret? It's this brilliant little design choice, this piece of architecture that makes these models way more efficient and a heck of a lot more powerful.
All right, so here's the game plan for how we're going to crack this thing open. First, we'll reveal the secret. Then we'll break down exactly what it is and why it's basically a smart gate for information. After that, we'll put it head-to-head with the old way of doing things, see which of today's top models are actually using it, and finally, we'll talk about why this whole idea of a gated future for AI is so important.
Okay, let's get into it. First up, the secret in modern AI and how it unlocks peak performance. This is where we really get to see how these tiny little details can have just a massive impact. And the secret ingredient is called Swiglu. Yeah, I know, it sounds super technical, right? But stick with me, because the name actually tells you pretty much everything you need to know. It's a mashup of two things: a Swish function, which is just a really smooth way to turn neurons on, and a gated linear unit, or GLU, which acts like a smart little gate. Put them together, and you get this awesome dynamic way for information to flow through the AI's brain.
So let's build on that idea. Next section, what exactly is Swiglu? We're going to look at the name and the game. Okay, so here's the thing you really got to get about Swiglu. It's not just some simple math formula you slap onto a number. No, it's a fundamental building block. In a lot of the big models today, the ones built on the transformer architecture, it actually replaces what used to be an entire hidden layer. It's a whole system for processing information, all in one package.
And that brings us right to the core of it, our next part, a smarter information gate. Let's dig into how this thing actually works.
Okay, so just follow the flow here. When some new information comes in, Swiglu splits it in two. You've got the value, that's the raw data, and you've got the gate. Now that gate path gets zapped with that smooth swish function we talked about. And then, here's the magic. The activated gate multiplies with the value. What does that mean? It means the gate is literally learning which bits of information are important and should get through, and which bits should just get tossed aside. It's a filter that actually thinks for itself.
And the benefits of having this smart gate? They're huge. For one, it gives the network this really precise, intelligent control over what it pays attention to. But maybe even more important, it solves this classic problem in AI called the dead neuron problem. That's where parts of the network just die off and stop learning completely. Because Swiglu is so smooth and can even handle small negative numbers, it keeps the whole training process stable. It's just way more reliable and efficient.
So, how does this new kid on the block stack up against what we used to use? Well, that brings us right to our next section, Swiglu versus the old guard. And trust me, it's a clear upgrade.
Yeah, this chart pretty much says it all, doesn't it? The old standard was this thing called ReLU. Super simple, if a number was negative, boom, it became 0. That's it, a fixed, rigid rule. But Swiglu? It's totally dynamic. It actually learns how to adjust based on the data it's seeing. So while ReLU was just a simple on-off switch, Swiglu is a whole structural component with a brain that learned gating mechanism. And that is how it avoids those dead neurons and keeps the training so stable. It's really a night and day difference.
All right, this all sounds great in theory, but where's the proof? Where is this actually being used in the wild? Let's get into it. Powering today's top models. Because, the proof is in the performance.
And here are the all-stars, right? You've got Meta's Llama 3 using Swiglu specifically for better training stability. Then there's Google's Palm, where it's a core piece of their advanced language architecture. And hey, it's not just for language models. Look at Ultralytics YOLO. That's a computer vision framework, and they use it to make the model more efficient with its parameters. So this is clearly not some experimental thing anymore. It's a foundational piece of the best AI we have today.
This brings us to our final section, and it's a big one. The future is gated. Simple code, powerful impact. Now,
You'd think something this powerful would be insanely complicated to code, right? But what's so beautiful, so elegant about Swiglu is that when you look under the hood, the core idea is surprisingly simple to put into practice.
I mean, for anybody out there who's familiar with PyTorch, this is basically it. This is the heart of Swiglu. You set up a gate and a value. You hit the gate with that SiLU activation function, which is just another name for Swish, and then you just multiply them. That's it. 3 simple lines of code. And those 3 lines deliver all of that dynamic, intelligent power we've been talking about. It's just a perfect example of elegant engineering.
So I'll leave you with this thought to chew on. We've just seen how a smarter, dynamic gate for information has become this absolute cornerstone of modern AI. It really makes you wonder, right? If this one relatively simple idea can unlock so much performance, what's the next simple, elegant innovation just waiting out there to be discovered?